The universe and all the celestial elements present in it is very strange, which we don't know much about. But with the help of certain powerful telescopes and technologies, humans are trying to understand the peculiarity of the universe and its elements, and the Milky Way galaxy is one of the points of interest. According to a recent research by an astrophysicist, the Milky Way is being torn apart by an unknown, unexplained force, which just shows that no matter how much we learn, the mysteries of our galaxy remain limitless. Science has been looking into the origin of these interruptions, which have been compared as cosmic bullet holes or something that has been hammered in. In this video, we'll talk about this object that is causing holes in our galaxy. Make sure you stay tuned to the end of the video to know what these holes are. But before we begin, welcome to Discover Space. If you want to be a part of our space journey, don't forget to click the subscribe button and hit the notification bell next to it to be The stream was found to have an anomalous kink brought on by close contact with a large and dense perturber. While keeping an eye on things, Barnaca noticed an odd change in the gravitational field. It appeared to be a cosmic fist that was dragging stars along with it as it tore any star in the galaxy. It is hence less likely to be a star of its own. Experts have also made detailed comparisons between the impactor and what is known as the galaxy's black hole. The comparison shows that whatever produced the jagged hole in GD1 lacks the signature flares or radiations of other black holes. While it's possible that some galaxies contain many black holes, the Milky Way is the exception. A second would be extremely rare in our galaxy. Barnaca speculated that if it was a black hole, it would be a supermassive black hole like the one at the center of our own galaxy. After ruling out stars and black holes, dark matter, an invisible substance that holds galaxies together and makes up around 25% of the universe's matter and energy, is the only thing that this hole could possibly be. All of space is held together by gravity. We are unsure of its true nature, but we are aware of how it works. There is a magnetic pull on an object, and the more bulk there is, the more alluring it is. The problem is that gravity is stronger than apparent mass. There must be about 27% more mass in the universe than what we can see in the form of stars, dust, and gas. Its unrecognizable nature has earned it the nickname dark matter. So far, scientists haven't been able to determine its composition. It's one of humankind's biggest mysteries. In fact, discovering that much dark matter would be a scientific feast. Even if this theory is still far from being proven, the unexpected observation does give rise to the possibility of using star streams like this one to constrain the properties of dark matter in the Milky Way. The best chance of solving those mysteries may lie in finding a large dark matter glob, even if it is sticky. Potentially, researchers may use the mass spectrum of dark matter substructures and even use tidal streams to pinpoint certain substructures. Despite the fact that the clumps that likely generated the holes have masses between 1 million and 100 million times that of the Sun, making them massive in comparison to our solar system, they are the smallest dark matter clumps that have been found. According to Barnaca's presentation summaries, dark matter might be the best answer given that there is no proof of any nearby objects that might have ripped through a tidal stream. Contrary to its name, dark matter doesn't reflect any light, and it's so hard to see. The only force that is generated is gravitational force, and in this case, it may have had a cosmic impact. Even though this theory intrigues scientists, they are careful not to draw too many conclusions because there is still a lot to learn about dark matter and its properties. If they can demonstrate that the impactor is composed of this intriguing material, they may learn more about dark matter. For example, it would show that dark matter may group together, supporting other scientific theories that are currently held. According to Dennis Urkel from Cambridge's Institute of Astronomy, dark matter is everywhere. Even though we do not fully understand what it is composed of, it penetrates the entire cosmos and serves as the framework in which astronomical objects consisting of regular matter, like galaxies, are put together. Tens of thousands of tiny dark matter clumps may be swarming in and around the Milky Way, according to current theories about how the universe was formed. There have allegedly been several of these dark matter building blocks left unused. These tiny clusters, also known as dark matter subhalos, are completely dark and empty of any stars, gas, or dust. Since dark matter is impossible to directly measure, observations of the motion of the galaxy stars can offer indirect proof that it exists. As a result, new techniques for studying subhalos, which are devoid of ordinary matter, must be developed. For instance, the particles that make up dark matter must be exceedingly large if they can be found in clusters that are smaller than a dwarf galaxy. This revelation will completely change how we understand dark matter. The mass of the tiniest clump of dark matter is strongly connected with the mass of the as-yet unidentified particle that dark matter is formed of, which allows researchers to reach this conclusion. More particularly, the size of the dark matter clumps correlates with an increase in particle mass. So the Milky Way might be impacted by dark matter. However, we aren't so certain about it. It would be fantastic if researchers were to find out if it was, since they could then tell us more about what dark matter is and isn't. Although there is no information regarding the impactor that is certain, researchers are working to eliminate possibilities and create new ones. Scientists only know that a very large object is tearing apart the Milky Way. As they continue to analyze their data and keep a lookout for new evidence, they can potentially have a better idea of what that something is. That's all for this video. Thanks for watching. If you enjoyed it, don't forget to like the video, also subscribe to the channel and hit the bell icon to never miss a new video. Also, let us know what you think about this hole in the comments section. Until next time.